Hi, hello everyone. So, welcome. First of all, I would like to welcome everyone. Those who are new and those who are used to, welcome to all of you. Hope that all of you are good and healthy and studying. Okay, so today's topic is the chapter from the subject mathematics. Right, today we are going to deal with mathematics, and in mathematics we are going to start with the chapter, very important chapter, triangles. So all my dear students, you all must be very familiar with the word triangle. Am I correct? Let's see what a triangle is. That's a triangle, am I right? So first I would like to go into basic details about triangles. A triangle is coming in the category of a polygon, right? So a triangle is a three-sided polygon. So a triangle is having three sides. A triangle is having three sides, and there are three corner points which are known as singular form. They are called as vertex, and let us name these vertex. If we say they are A, B and C, so A, B, C is the vertices of the triangle. The plural form is vertices. So the triangle is having three vertices, three sides, and due to these sides some angle, there is an inclination of this line AB over this line BC. So that inclination is the angle between the two. So there is one angle, let us say angle number 1. This is angle number 2 and this is angle number 3. So overall it is also having three angles. So from that you can get to know that why the word triangle has been used, because it is having three angles. So 3 stands for tri, 2 stands for bi. So triangle, so that's its name, that from that it has got its name, that is triangle, right? Okay. So from the previous class you have got the information and details and knowledge about the congruency. You know what is congruency? You know what is congruent figures? If you are not able to recall, let me make you remember that what is congruent. Congruent is word used in mathematics when two objects or two shapes are exactly equal with each other. Equal means in all respect, their shape, their size, everything. They are such that if one of the object is kept over the another object, they just overlap one another. No of them is bigger and no of them is smaller. That's the meaning of congruent. So congruency was explained in detail in class 9th. But in class 10th we are going to discuss in detail about the similarity of triangles. So let's go and discuss what is similarity. See, two triangles can be said to be similar triangles if there are two conditions. There are two conditions where two triangles can be said to be similar triangles. Let us say there is one triangle ABC and another triangle is ABC, and what is after ABC? I am forgetting ABCD now. Okay. D, E, F. At least I remember the ABCD. So ABC and the another triangle is DEF, right? Now these two triangles can be said to be similar on two conditions. You may write down what are the conditions for what are the conditions for two triangle? What are conditions for two triangles to be similar? What are conditions for two triangle to be similar? So we were discussing that what are the conditions for the two triangles to be similar. Okay, so what are the conditions for the for two triangles to be similar? So the first condition is their corresponding angles are equal. Yes, you may write down. The first condition is their corresponding angles are equal. Their corresponding angles are equal. Corresponding angles, by corresponding angle we mean what? If we are selecting angle D, then we are going to observe here angle B. If we are observing angle E, then we are going to observe here angle C. If we are observing angle F, then here we are going to observe angle A. So that means the corresponding angles. So angle D, if angle D is equals to angle B, angle D is equals to angle B, angle E is equals to angle C, and angle F is equals to angle A, then the two triangles can be called to be similar. Yes, they can be called to be similar. On two angles also they can be called to be similar. There is double angle theorem, which says that if two angles of a triangle are equal, they are similar triangles. Similar means they are looking similar in shape, but they are not necessary. It is not necessary that they are equal in size. Here is the difference between congruency and similarity. Similar, two things can be similar, like this, you can say this pen is similar to this pen. We can say that if their sizes are not same, this is smaller and this is bigger, but two congruents are only, we can say, when they are exactly same shape also and same size also, then they are said to be congruent. So that is the difference between similarity and congruence. Here by similarity we can say here that the triangle DEF is similar to triangle BAC, or we have selected the name, so we can say that triangle DEF is similar to, this is the sign of similarity, is similar to triangle, sorry, I am making it angle, it's triangle BCA. Triangle DEF is similar to triangle BCA. This we can say when the angles, corresponding angles are equal. When the corresponding angles are equal, then we can say that the two triangles are similar. But by similarity it does not mean that this triangle is equal to this triangle. No. By size wise, this triangle may be smaller and this triangle may be bigger. But similarity can be there. So the two triangles are similar when their corresponding angles are equal. Second condition says that two triangles can be similar when their sides are proportional. Two triangles can be similar if their sides are proportional. If their sides are proportional. Two triangles are similar if their sides are proportional. By proportionality we mean what? By proportionality comes the sense of ratio. Yes, there comes the sense of ratio. So what we mean here is that if there is a triangle, let us name this triangle as A, B, C. There is another triangle, let us name this triangle as D, E, F. So these two triangles can be said to be similar if their sides are proportional. By proportionality we mean what? We mean that the ratio of their corresponding sides should be equal. So ratio of corresponding sides means what? If we are selecting AB, then we are going to compare it with DE. So the ratio of AB to DE should be equal to the ratio of AC to DF. And that should be equal to the ratio of CB to FE. Then the two triangles are said to be similar. This is the second condition. When the ratio of their sides is same, constant. The value of the ratio is constant throughout. For example, if it is of 2 centimeter, this is of 1 centimeter, so the ratio will be 2:1. So if this is of 4 centimeter, this should be of 2 centimeter. Again the ratio is of 2:1. So if this is of 3 centimeter, this should be of 1.5 centimeter. Again ratio of 2:1. So then in this case also we can say that the two triangles are similar. So these are the two basic conditions on which similarities are told between two triangles. Getting my point? Now there are some results which are applicable on similar triangles. Yes, these are very important. And in that comes the first one is the basic proportionality theorem, which is also known by the name of Thales Theorem, right? So please write down basic proportionality theorem. Or also known by the name of Thales Theorem, also known by the name of Thales Theorem. So my dear students, I was talking about some results on similar triangle. When two triangles are similar, there are some points which can be said about them, and those points are known by theorems. So there is first theorem which is important for you all because its proof is also asked in the examination. So the first theorem is basic proportionality theorem. Yes, you heard me right. The first theorem is basic proportionality theorem. It is also known by the name of Thales theorem. Also known by the name of Thales theorem. So what does this theorem says is that suppose there is a So this theorem says that if there is a triangle, let's make a triangle. If there is a triangle and there is a line, which is parallel to one of the sides of the triangle. Let us name the sides, let us name the vertices. So there is a triangle ABC and there is a line which is, let us say, line L, which is parallel to BC. So it is intersecting the triangle at two distinct points. Let us name these points as D and E. So we can say that DE part of the line is parallel to BC. DE portion is parallel to BC. So the basic proportionality theorem says that if a line, first of all write down the theorem. The theorem is saying that if a line is drawn parallel to one side of the triangle, to intersect the other two sides, in distinct points. Distinct means different points, two different points. Here is one point and here is another point. Then the other two sides are divided. Then these two sides are divided in the same ratio. Yes. So what does it mean? It means that AD upon DB is equals to AE upon EC, because it is saying that if a line is parallel to one side of the triangle, it will obviously intersect the other two sides at two distinct points. Now it will intersect in such a way that the two sides, the ratio of the two sides, the parts of the two sides will be proportional, will be in the same ratio. That is what Thales theorem says. AD upon DB is equals to AE upon EC. Now we are going to prove that how Thales came to this result. So let us see this in detail. So in order to understand this theorem, let's see how Thales got to that result. So we can say that this is a solution. So what we will do is, by construction draw a perpendicular by construction, draw a perpendicular from D to side AE. Now please listen carefully. ADE is forming a triangle within a triangle. It's a small triangle inside this bigger triangle. Am I right? Now in this triangle, if we take AE as the base, so a perpendicular can be drawn from the vertex which is opposite to the base. So the vertex which is opposite to the base is D. So from here we will draw a perpendicular. And the name of that perpendicular, let us say it as M. It is meeting the line AE at point M. So DM is one of the perpendicular. Again, draw another perpendicular from E to side AD. Yes, you heard me correct. From E point to the side AD. So if AD is going to act as a base, so the opposite vertex is E. From here we will draw a perpendicular. So that's the perpendicular, and let us name this perpendicular as EL, right? Okay. Further, what you need to do is you need to connect point E with point B, and from here point D with point C. Join BE and DC. These things you have to do by construction. After doing this, we will be able to reach to the result of the Thales theorem, that how Thales got that result. So let us see. Now observe this triangle from the left side, that is this side, and if you are able to see the triangle ADE, so can you tell me what will be the area of triangle ADE? Do you remember what is the formula of the area of triangle? Yes, correct. Half base into height. Half base into height is the area of the triangle. So if we are observing from the left side, that is the AD side. So AD is the base. So area of this will be half multiplied by base. Base is what? AD. Multiplied by height. Height is what? The perpendicular. So perpendicular is EL. So half AD multiplied by EL. That's correct. Similarly, can you please tell me what will be the area of triangle DEB? First of all, learn how to see the triangle DEB. So which triangle I am talking about now? Now I am talking about this triangle DEB, this triangle. So what is the area of this triangle? So see, there is a thing. The formula is going to be the same, half base, and if we see, this side is going to act as base, that is BD. BD is acting as base multiplied by height. So what will be the height of this triangle? So height of this triangle will be no other than the side EL, because the base of this triangle, if we produce it, then the base of both the triangles are same. So a point which is opposite to them, that is E, a perpendicular line from it, that is going to be the height. So whether you are talking about this triangle, if you are observing this as the base, the height is going to be EL, and if you are talking about this triangle, this is the base, the height is again going to be EL. So in some cases, the height, the perpendicular, the altitude, whatever you call, may go outside of the triangle. Yes, you can see in this triangle, if there is a triangle like this, what will be the height of this triangle? We need to produce this side, and then we will drop a perpendicular. This will be called the height of the triangle. So here the height is actually outside the triangle. So that is why here also EL, which is outside the triangle, is being called as the height of the triangle, which might be a point of confusion for many of students. So height can be outside the triangle. So again, half base into height. Now divide these two equations. Let us name this as equation number first and this as equation number second. Divide them. On dividing, what you will see, half and half will be cancelled, EL will be cancelled with EL. So what we are left with is area of triangle ADE, area of triangle ADE upon area of triangle DEB is equals to AD upon BD. Am I correct? AD upon BD. So let us say this as equation number third, and all this information let us keep it aside for a time being. Okay. Now observe the same triangle from the right side. Observe the same triangle from the right side. So from the right side, if you are taking this side as the base, this side as the base, so base is what? AE. So again we can say that area of triangle AED, area of triangle AED is, base is this time AE, so is equals to half multiplied by base, base that is AE into height. So height is what? The perpendicular. So the perpendicular this time is, this one. dm. So the area of this triangle is going to be half of AE multiplied by dm. So that's the area of this triangle. Let us find out the area of another triangle. This one, that is, the name of the triangle is, yes, what is the name of the triangle? DEC. Yes, you are correct. The name of the triangle is DEC. So what will be the area of triangle DEC? So the area of triangle, in the same way, the formula is same, half base into height. Now base is this one. This one is going to act as base. So it is EC multiplied by height. Now again, the height of this triangle is outside the triangle. The height of this triangle is outside the triangle, and the height is dm. The height is dm. How? I have explained in the previous one. So again, name this equation as equation number 4 and this as equation number 5. Divide both of them on the left hand side as well as on the right hand side. On the right hand side, half and half will be cancelled. dm will be cancelled with dm. So what we are left with is area of triangle AED upon area of triangle DEC is equals to AE upon EC. AE upon EC. This we can say as result number 6. AE upon EC. So till now what we have got to know is that two important results we have obtained. And those important results are area of triangle ADE upon area of triangle DEB is equals to AD upon BD. And here area of triangle AED is equal to AE upon EC. Now in these two important results, what you can say about the numerator? The numerator here is, in the third one is area of triangle ADE. Am I correct? And in the sixth one, the numerator is area of triangle AED, if we are talking about the left hand side. So guys, please tell me, ADE, can you see the triangle ADE? And AED, can you see the triangle AED? Are these two different triangles or the same triangle? ADE and AED, are these two different triangles or same triangle? Same triangle. So their area is going to be equal, no doubt in that. If we are talking about the same figure, how can its area be different if we are changing the name? Obviously the area is going to be the same. So the numerator is same. Let us check about the denominator. What we can say about the denominators? So in the denominator case, we have got the numerator to be same. The case of denominator, in the first part we are talking about area of triangle DEB. And in the sixth point we are talking about area of triangle DEC. Now observe these two triangles carefully. DEB, the red shaded one triangle, and DEC, the green shaded one triangle. These two triangles, what we can say about their areas? We can say that their areas are also equal. Their areas are also equal. Yes, they are equal. You will say, how, sir? I will tell you that there was a theorem. In that theorem, it was being told that whenever two triangles are drawn on the same base and they lie between same parallel lines, then their areas are equal. Yes, you heard me right. You can write down the theorem. This theorem was in class 9th. Yes, it was there. The theorem says that when two triangles are drawn on the same base, here the same base is what? DE. The same base is DE. So when two triangles drawn on the same base and they are between same parallel lines, their areas are equal. Their areas are equal. So area of this triangle will be equal to area of this triangle. So now you can see that numerator and denominator both are equal. So when numerator and denominator both are equal of the left hand side, LHS of both of them are equal. So RHS will automatically become equal. We'll say when LHS of point number 3 and point number 6 are equal, their RHS right hand side will also be equal. So what are their RHS? What are their RHS? Their RHS is AD upon BD. Yes, their RHS is AD upon BD is equals to AE upon EC. AE upon EC. And guys, is it not the Thales theorem? Is it not the Thales theorem? Yes, that was the Thales theorem what was saying. So this is the proof of Thales theorem. This is the proof of Thales theorem. This way you have to proceed step by step to get to this result. Now there are some results associated with the Thales theorem. Some more results can be drawn out of it. Let us see them. So now if we are talking about further more results based on Thales theorem, so we can say that AD upon BD is equals to AE upon EC. Am I right? Add 1 to both the sides. Can be done. No harm is there. So when we add 1 to both the side, taking the LCM, BD will become the LCM, AD plus BD will get here, and here EC will be the LCM, and we will get AE plus EC. So AD plus BD will be what? Will be AB, the entire side. And AE plus EC will be what? AC, the entire side. So then after that we can do the reciprocal. So we can say that BD upon AB is equals to EC upon AC, which means that BD upon AB, this portion of the triangle divided by this whole side of the triangle is in the same ratio is what this portion with this side of the triangle. this portion BD divided by the entire side AB is equal to EC divided by the entire side AC. So that result can also be explained on the basis of Thales theorem. So as we are talking about the lower ones, we can also say about the upper portion of the triangle. The upper portion means what? That AD upon AB is equals to AE upon AC. That is the upper part of the triangle. The ratio of the upper part of the triangle, that is this portion AD upon AB is equal to AE upon AC. This part divided by entire side is equal to this part divided by entire side. This part divided by entire side is equal to this part divided by entire side. So these are some of the important results of the Thales theorem. I hope you all must have understood that how the Thales theorem is derived and what is the proof of it, how we can solve it, what are the points which we have to keep where we have to keep the attention, and what are the reasons behind the small points. I hope that this will bring clarity to you. If there is any doubt, you can comment, you can post. I will come up again with the next theorem in my next video. Till then, bye bye, take care.